Welcome to Innventuring, where we talk about what it actually takes to turn breakthrough technologies into companies with billion-dollar valuations. In each episode, I sit down with the innovation leaders, the investors, the operators, the experts who are building these companies in real time. This is Innventuring, the science of company creation. Today, we're going to talk about something that permeates every area of our lives. It helps us in so many ways, and yet creates a significant challenge that simply cannot be ignored. Roughly 400 million tons of plastic are produced globally every year. A significant portion of that goes to waste, and only about 10% is ever recycled. The rest goes to landfill, it's incinerated, or it just becomes litter. For decades, the gap between where plastic ends up and where it could go has been one of the most challenging and stubborn problems in materials science. Today, we have two people who are actually doing something about it. This is Innventuring, and I'm your host, Chad Arnold. Let's get into it. Dr. Bill Grieco is the CEO of Refinity, an exciting new Innventure company built specifically to convert hard-to-recycle plastic waste into usable hydrocarbon feedstock. And our second guest is Dr. Jesus Atias from Dow Chemical, one of the world's largest materials science companies and a central partner in bringing Refinity's technology to scale. Welcome to both of you. Jesus, I want to start with you. Can you share what your role is at Dow? And from Dow's perspective, how do you think about the role of plastics today? And what's changing about how the industry is approaching sustainability?
Thank you, Chad, for that question. My name is Jesus Atias, and I define myself as with two titles, the uniter and the developer. And I'm going to break that down for you in a sec. The uniter, because my role in the circularity of plastics is about bringing people together, and it's about bringing companies together. The second piece about the developer is really starting something that is still in its infancy and is still being built up. Plastics are foundational. That one, there is no options there. They enable the food safety, healthcare, lightweighting of vehicles and other infrastructure. Put high quality piping in our systems. It increases the energy efficiency of what we go and build. And in all those aspects, you find plastics. So the challenge is not plastics. It's really the waste that we generate and after the intended use of those plastics, and the system that it needs to be designed to ensure that something that we spend the significant amount of time where the industry evolved from a linear economy and now trying to bring what is at the end of that linear economy where you buy, you use, and you throw. That throw now is becoming you bring back to the beginning of that cycle. And that's pretty much a lot of the work that we do at Dow in the space that I happen to be in. Really helping that structural inflection point that we are as an industry to bring sustainability at the forefront. Sustainability is something that it can be sustained over time, and it also allows for materials to come back as a resource to be able to make new plastics again and again. So at the end, the developing part is close to my heart. I've been fortunate enough in my 20 years at Dow to work in a lot of new spaces. And in order to be successful, we really have to bring all minds together, all perspectives, because this is quite the challenge for our society. But we do need to tackle it all together.
That's great. Yeah, it's going to take a lot more than a single entity to try to tackle this problem. It's huge. It's a big challenge, and I'm glad to see Refinity and Dow tackling that together. I want to turn it over to you, Bill. Tell us what Refinity is trying to accomplish.
Yeah, thanks, Chad. It's interesting because a lot of this will build on some of the comments that Jesus just made. At the highest level, what Refinity is trying to achieve is ultimately the commoditization of plastic waste, right? Having plastic waste as a viable feedstock, a bankable feedstock that will allow many industries, the petrochemical industries and others all across the process industries, to choose among a range of feedstocks. Today, those feedstocks are largely limited to fossil derived, right? natural gas or crude oil derived feedstocks. We want to enable plastic waste to be part of that mix and provide for raw material optionality, feedstock diversification, hedging, et cetera, for players across the petrochemical industry to choose from. So, as we think about what we're doing specifically at Refinity from a business perspective and a technical perspective, we're looking to convert mixed plastic wastes that today are largely landfilled or incinerated and significantly underutilized or not utilized at all, to convert those to circular drop-in chemicals. So what that looks like for us is precisely depolymerizing these plastic wastes. So for folks that don't know, plastics are made up of polymers, right? That's the same thing. A polymer is a chain of chemicals strung together to give certain structure and functionality. We are commercializing a process to break those polymer chains down into the constituent parts from which they were made. Polyethylene is made from ethylene. Polypropylene is made from propylene. We're looking to break those polymers down, make ethylene, make propylene from polyethylene and polypropylene, respectively. And our goal ultimately is to build plants, conversion plants, Refinity conversion plants, that match up with the needs of the petrochemical infrastructure that we have today. So we have a couple of different potential plays. One is to build plants to produce circular ethylene and propylene monomers that feed directly into the petrochemical infrastructure as it exists today and take advantage of the capabilities that that infrastructure brings. Take advantage of their downstream separations, take advantage of their purification technologies, and enable for a petrochemical customer to which we connect our plant, enable them to produce circular products from the circular ethylene and propylene that we produce and supply to them. So the process that we're commercializing is really built around a fluidized bed technology that the core parts of which we licensed from the VTT Technical Research Institute in Finland. The way this technology works is pretty simple. We have a core process where we're flowing very hot sand in a reactor. We feed solid plastic waste into that system. The solid plastic hits the hot sand. First it melts, then it vaporizes, and under conditions that we can control very precisely, conditions of temperature and residence time and pressure, we can break down those long polymer chains into shorter chains and still shorter chains. We can stop it at different points along the way, or we can go all the way down to the individual chemical compounds, the monomers from which those polymers were made. And so, this capability that we have and the process that we have with tight control of temperature and residence time means that we can convert plastic waste to those monomers at very high yield. And this is pretty different than other technologies. And I think we'll talk a little bit more about how we compare to and differ from other competitive processes. But unlike those other ones, we operate at high yield and high productivity. When we combine our core system with the petrochemical operations, we believe that we can get 2 to 3 times higher productivity, 2 to 3 times higher yield from plastic waste to the monomers that the petrochemical industry is interested in producing. That is differentiating. That is really unique. That's a breakthrough piece that we're bringing. But ultimately, it's the first step along this path of commoditizing plastic waste and driving circularity and kind of meeting some of the elements that Jesus mentioned before to bring the industry to a new place of operation in the future.
Exciting. Very cool. Jesus, I want to go back to you. Dow is fundamentally a material science company. Obviously, there's a lot of expertise there. How does that expertise shape the way you evaluate, you support circular economy solutions like Refinity? And how does that circularity fit into Dow's long-term material strategy beyond a single technology or a single partner?
Well, thank you for that question. And building up on what we just heard from Bill, and taking a bit of a step back, when you look at what circularity means to Dow, it is a system transformation. And this is not a specific project, but it's really a transformation of an ecosystem. And there are many pieces that need to evolve and connect with each other to be able to give us not just circularity, but also the carbon equation is important. That means I always often talk about the size of the circle matters. The broader that circle, if you need to connect a lot of dots to get to the recycling of plastics, you might end up spending quite a bit of energy and likely money doing that. So we gotta also be conscious about this circular economy that we are building up. It only works thinking of the end in mind. So we always take up an approach where we're thinking with the end in mind. We got to make sure that our customers and the applications that we serve, that output coming out of our plants have to maintain that expected performance and reliability that our customers are used to. Now, as a material science company, we do bring that deep understanding of the polymer chemistry, that property to performance equation that is important, because you do have a wide range of uses that I mentioned at the beginning. You can go from lightweighting vehicles, now evolving into electric vehicles, and what all that wires make into the needs that the plastics are gonna they're gonna be part of that the vehicle are gonna be required. Uh, Data centers, now the AI is really a disruptor in terms of like growth for our business, and in other properties like food packaging, that the needs for growing and feeding the world remain more and more relevant. So at the end, when you start thinking of all these properties of our products and the performance and the things that we're asking these polymers to do, uh, and then we start thinking of the inputs for that system for us, it really is critical to bring that material science company background. So when it comes to the material science lens, that will help us answer two key questions. Can this material re-enter our high value uses? Because at the end, we want to have a fit for purpose. And when it comes to working together, it's not just designing the inputs and making sure that the outputs of our systems are providing the requirements that are needed, but also designing those products to make sure that it makes it easier for the ecosystem to bring them back as the beginning of that loop. So the design for recyclability is an important platform that Dow has been advancing, and also the pathways to go back to from end of life waste to raw materials. And that could be through mechanical recycling, chemical recycling, renewable feedstock. So there are different pathways. So at the end, we don't believe that the industry is at a point to say there is one specific solution. We need a suite of solutions. And the scalability of these solutions is going to be critical. And that's where we come in also as partners to support anything that might be needed to be able to scale these technologies and understand how they become part of the ecosystem that we're building together.
That's great. Thanks, Jesus. You mentioned the suite of solutions. I'm going to kick it back over to Bill. These technologies is one of those solutions, Bill. Can you just briefly talk about how it's different than the other technologies out there that are trying to accomplish the same thing?
Sure. And actually, maybe before I do that, I want to build on a couple of things that Jesus just mentioned. So number one, maybe this would surprise some individuals. We're developing a particular technology platform, but I'm actually rooting for there to be a lot of winners. Right? There's a place for mechanical recycling. If we often talk about 9 to 10% of plastic waste being recycled today, that's a very small fraction of what could be done. Mechanical recycling accounts for the lion's share of that. Now, personally, I don't believe that that is scalable to be much more than a few percent more than it is today, because scalability tends to be a little bit limited, but it has its place. Other technologies like PureCycle's solvent recycling is complementary to what we're doing. Both of those technologies require certain kinds of feedstocks. They require feedstocks that often tend to be a little bit purer and tend to be a little bit higher cost when we think about it. We're happy for those technologies to take the feedstocks that we'd rather not use. There's other technologies out there, right? I mentioned earlier, we're doing precision depolymerization of largely polyolefins, polyethylene, polypropylene. There's other depolymerization technologies for other polymers. Things like PET bottle polymer. That can be depolymerized using methanolysis or hydrolysis technologies, and companies are doing that today. We all have a place in the market. And in fact, when we're all successful, we will kind of raise the level of the ocean for all of our boats. It will incent, I believe, the waste industries. It'll incent ultimately all of us as consumers to do the right thing with waste writ large, send it to the right outlets. We'll get what we think can be dirtier mixed plastic waste that others can't take, and we'll convert those in a way that those other players can't. They'll take different raw materials that are more more specified for their processes, and they'll turn them back into viable products. Again, we all win together. And this idea of transforming an industry, particularly the waste industry, is only going to happen with a large suite of solutions, broad suite of solutions where we all win together. So that's kind of the big picture. If I narrow it down to advanced recycling that's relevant to the kinds of plastic waste that we target, the incumbent technology that we typically compare to is pyrolysis. And I mentioned really briefly in my earlier comments that we operate at higher yield than typical pyrolysis processes. So one of the reasons is that the specific equipment that is used in some of those other processes, I'll say maybe doesn't scale quite as well as our core fluidized bed technology. The technology we're using is currently practiced, different application, but it's practiced at very, very large scales in refining and petrochemical, or rather petroleum refining and the production of transportation fuels. And given that, we're very confident that we can scale across those ranges, from small distributed manufacturing to larger, more integrated manufacturing plants. That's not as true for pyrolysis, where the technology tends to overheat or, to overcook the polymer as it's converting it back to some potential product. When it overcooks it overheats it. It leads to the production of byproducts that typically can't be sold, or if they can be sold, just can't command a very high value in the market. We don't do that. We control the temperature time history of the material that we put into our process. We make more of the plastic that's going into viable, usable product, into the ethylene and propylene monomer that we want to sell to petrochemical customers, and into other materials that we can use to run the process, to fuel the process. We have very, very high overall conversion. And so, I certainly do think that our process has unique advantages. Kind of bringing it back to the initial point, there's enough plastic waste in the world to go around for there to be a number of winners. We just happen to be, I think, uniquely advantaged for the particular application, and unique in the sense that we're producing circular ethylene, circular propylene directly in a way and at a higher yield than what others are doing today, or frankly not doing today.
Yeah, that's good. As you said, there's many other technologies, many other solutions that need to be a part of this. This whole infrastructure. I want to kick it back over to Jesus. I want to ask you a question about your vetting process, sort of how you look at technologies. Can you talk about how Dow evaluates circularity technologies, and what led Dow to engage with Refinity as part of that sort of that broader learning experience?
Well, thank you for that question. And before jumping right to the answer, really is something that Bill mentioned that resonated with me. I get to talk to my neighbors almost weekly. They already know that I work in plastics recycling, and the most common question that I get from my neighbors is, "Can I recycle this?" And that happens when it's the day to put our recycling bins outside. And we're fortunate that in my community we do have access to recycling. Over 50% of the households in the U.S. do not have access to recycling programs. So when we start talking about the transformation of our system, it needs to start also thinking about having access to actually put this plastic waste in the recycling bin in the first place.
Yeah.
Second, it comes about understanding. I think we made it quite complicated sometimes with all the experience that I have of being fortunate to work in this industry. I sympathize with my neighbors because they really struggle to understand what goes where. And there are a lot of different types of plastics.
Me too.
And when it comes to the figuring that piece out, just making things easier. And I've been fortunate that in this industry, I started working in partnerships with some of our customers. Reynolds Consumer Products is one of them on the Hefty Renew program. Really trying to understand the collection of hard to recycle plastics. How can we make this easier for communities, and how can we open the access to rural areas and other areas that might not have access to the regular recycling program? So a lot of efforts happen on the collection side. As Bill mentioned, there is quite a bit of opportunities on the waste management piece that we have in North America. Dow has a close partnership with Google X, applying AI. So if somebody put the wrong thing in the wrong bin, we have now technology that is evolving so fast to have that molecular vision. So now you and I don't have to look at the back of that plastic to see if it's a number 1 or a number 2 or number 3. With these molecular visions that can be applied to the existing infrastructure, we might be able to, at some point, get to distinguish between the hard to recycle films, the flexible packaging, and start to divide things where to make sure that we're sending the right materials to the right places. Mechanical recycling was mentioned by Bill. That's the lowest carbon footprint solution that we have. And certainly we want to favor as much of that plastic waste down that path. That one was not a partnership for that, it was a direct investment. Our strategy in this circularity space is partnerships and direct investments. Direct investment goes where we believe the technology advancement needs for that space are really close to our core competencies. We're a material science company, as you mentioned before. So acquiring Circulus a year and a half ago, which is a mechanical recycling, one of the largest in North America, became something that close to our core capabilities. So we have been working really hard trying to advance the mechanical recycling of films and flexible packaging through the Circulus acquisition. But at the end, you see that the outputs of there are still always some yields. That there will be always some leftovers, things that did not get recycled, and that's where the waste of a process can become the feedstock for the next process in. So when we go and start thinking on how to establish partnerships in this space, is when we believe, bringing our core competencies together with the partners' core competencies really create an important synergy in this space. So when you think of the due diligence, I've been very fortunate in the last 5 years. I've been leading those efforts in North America, and when we look at the due diligence, the technology is important, but also the team working behind those technologies is, I would say, even more important. There has to be passion, there has to be technical credibility, there has to be deep understanding on having the right scale up approach of these technologies. This is not an easy task, and I just really a lot of appreciation for people like Bill and Refinity as a company, because it just takes a lot of hard work to be able to go from a very good idea to an actual innovation, to an actual demonstration plan, to an actual solution for the industry. So we are looking at partnerships in a way where we help each other, we can bring synergies together and be able to advance the circularity of plastics overall.
That's really interesting, Jesus. I'm just curious. I'm sure others listening would be curious too. Dow's a big company, right? Why does Dow see value in engaging these partnerships, right? You just mentioned several, Refinity also. Why do you see value in those structured collaborations versus just doing it internally? Hire a team and do it all internally.
Yeah, that's a great question, and I appreciate the follow up there because it comes down to 3 words, in my opinion, and it's focus, speed, and the risk tolerance. So at the end, the focus teams really working through the their core competencies of advancing those specific technologies are important. We just don't have the bandwidth to advance, and that just dilute efforts. So we prefer to, in areas where there is synergies created with our partners, we bring the focus. We provide what might be of relevance from where we sit, but at the end, looking at a focus team that is really speeding up the scale up of technologies and helping us address some of the risk that comes with new technologies. So it comes down to having faster iterations when it comes to the demonstration of these technologies, having dedicated teams, also access to a broader innovation ecosystems. We do have a lot of capabilities. We're a large company, but I can tell you our perspective is needs other perspective to come together to be able to advance these complex problems that we have in front of us. So this model will allow us to stay close to innovation, preserve the flexibility, because at the end there are several pathways that are being pursued. So allow us to have that flexibility and reinforces the point that we're committed. This is not a nice to do. This is something that the company is fully committed to do, and we want to do it fast. And through partnerships where we find that this industry is can advance faster in this solving the waste problem that we have.
Makes a lot of sense. Makes a lot of sense. Bill, I want to come back to you and dive a little bit more into Refinity. I think people that maybe are hearing about Refinity for the first time, can you, I think they would want to hear this. How did Refinity come about? How did it come to be? And then, what's been accomplished so far since the inception? And then what can we, I'm not going to hold, I don't want you to say anything forward looking that you have to commit to, but what can we expect to see in the next year, year and a half from Refinity?
No, that sounds good, Chad. I mean, in part, you're looking for me to tell the abbreviated origin story.
Yes.
Jesus's last comments couldn't be a better setup for that, a better entree to it, because so for folks that don't know who are listening, prior to launching Refinity, I was the chief technology officer at Innventure. And so I was in that role from the beginning of 2022 through the end of 24 when we launched Refinity. And when I started at Innventure, among the many things that I was doing as I was getting my sea legs at Innventure was canvassing my network of contacts at multinational companies. And so I had pretty deep connections with a number of folks at Dow because, one of the companies that I used to work for is, at least in part, now part of Dow. And so there's common history, common connection points. And so we talked to folks at Dow about the Innventure business model, and many of the things that Jesus just mentioned in terms of their view, Dow's view on partnering and, if you want to call it, open innovation and building the network, resonated with me. And I think our model resonated with the context that I had. And so we Innventure started looking at some opportunities, technology-driven opportunities from Dow, and we collaborated a bit. We looked at market needs and so forth. And one of the key things that kept popping up was the need for solutions that solve this circularity problem. How might we go about valorizing different waste streams, turning waste into valuable products that would serve different industries? And so that was the backdrop for a lot of the work that our team was doing. We were out then canvassing and looking for alternative waste to value technologies. Our team, both the people who are in part at Refinity now and others at Innventure, had looked at, dozens, maybe many tens of waste to value technologies over the years, and we had a sense of what worked and what didn't work. We also had a deep relationship with VTT, the Technical Research Institute in Finland, who originated the technology and from whom we licensed the core fluidized bed technology. Our chief operating officer, Adam Javin at Refinity, was previously a serial CXO at Innventure working with me. He had this connection to VTT. So sort of this combination of working with Dow, understanding market needs, trying to figure out exactly what could be a new technology solution to satisfy an unsolved problem in the market, converged. We assessed did deep due diligence on the fluidized bed technology that we ultimately licensed. We worked with Dow to identify some mechanisms of collaboration for us to work together. Ultimately, we built a business case around that, and we launched Refinity at the end of 2024. So in some ways, as I look back, it's a very natural story to tell. We were working in the space. We understood it. It was a nice collaboration already underway with folks at Dow that helped us understand what the needs were, and then ultimately for us to find and license and then build a technology into what we have today. So that's the rearward looking view, the origin story piece. The other part of looking back is that it's sort of difficult for me to realize that we've only been a company for 16 months. We have a core team that's very small. One of the things that we did early on, again, I mentioned our COO, Adam Javin, our CTO, Dr. Ignacio Paulo Rivera, who's worked across multiple industries. The three of us, the C-suite at Refinity, have a really deep network across different industries. We've worked with countless engineering firms and consultants, equipment providers, research institutes, academic institutions, national lab complex, et cetera. And so we leveraged that network and continue to today to build sort of a virtual team that transcends our core group. And it allows us to do a lot of the things that Jesus said they were looking for or are looking for, right? We are a team that punches far above our weight. We move quickly, we set aggressive goals, we go achieve them. And that's been our story for the last 16 months, and it'll be our story going forward. So you asked specifically what we've done. So working with VTT, again, the technology originator, we've been using their capability to validate that the core fluidized bed technology does exactly what we believed that it would do, but doing it with real world plastic waste. So taking material that we sourced from the field, running it at different scales at their facility in Helsinki, Finland, and validating that we can produce liquids and gases like ethylene and propylene at the yields and the product quality that we believed we could. And we've validated that we can do that across a range of operating conditions and across a range of raw materials. So that's sort of the core piece. We've been optimizing conditions, figuring out, where some of the boundaries are and thinking through how that will map onto ultimate larger scale and commercial designs. But at the same time, we kind of realized that that alone was not enough. That core piece is critical. It's necessary, but not sufficient. So we've bolted on to that some novel reactor designs, the Refinity dual-zone reactor design that we've been talking about. Our team patented that along with some unique operating conditions and applications for some intransigent raw materials that we believe we can process that others can't. That extended our core internal IP portfolio. But again, we didn't stop there. So Jesus mentioned earlier that, or sort of alluded to earlier, that one of the things that's challenging about the plastic waste that we all deal with is that we get performance by combining lots of materials into one functionality. The potato chip bag is one great example of that, right? It's got polyolefin layers, it's got adhesive layers, it's got printing, it's got metallization, and it is a uniquely tough material to process because it's got all this disparate material in it. So with tough materials like that in mind, we licensed a technology from a US university that is focused on handling and feeding to process materials like that into a conversion system like ours. And we're beginning to work with them to explore a range of tough raw materials like that one and others that we'll be able to process. But again, we didn't stop there. We added to that the license to a suite of catalyst technologies from the US National Lab Complex to allow us to convert the mixed olefins that we're planning to make for the commodity market, the ethylene and propylene, to convert that through a process to tailored hydrocarbon liquids. Process is called oligomerization, so stringing these chemicals together to make longer chains that could potentially be used as jet fuel substitutes, as things like sustainable aviation fuel or SAF, that's called SAF, or SAF precursors. And so, we've built out a broader range of solutions to build kind of an end-to-end portfolio of technology solutions to satisfy plastic waste to ethylene and propylene monomer for the commodity olefins market, as well as plastic waste to customized circular hydrocarbons for specialty markets like SAF and SAF precursors and so forth. And we're working to demonstrate that end-to-end process to all of those components at a larger scale by the end of this year. So that's one piece. In addition to that, we're thinking about scaling up. What comes next? So over the course of the last 16 months, again, we've developed conceptual designs for a full-scale commercial plant. For us, that's nominally 100 to 150 kilotons per year of waste processing capacity. But we also did that for a first commercial demonstration plant scale, nominally 10 kilotons capacity. And we did that up through the end of last year and the early part of this year. We hope to start the construction of that later this year. That'll be a modular construction. It'll be factory built by an equipment provider and then deployed to a site that we'll still choose. We're in the process of site selection now, and we'll talk about that more in the coming months. But we'll deploy that likely late 2027, early 2028 for startup and production in a revenue generating 10 kiloton commercial demonstration plant in the mid 2028 timeframe. So this is just a glimpse into what our plans are, what we've done, and what our plans are over the next months and next couple of years.
Oh, that's great. It's exciting. I want to ask you really quick about one element of that, and then I'm going to pose a question to both of you after this about what any further detail on the operational build out of the Refinity company. So be thinking about that, Jesus, also. But Bill, you talked about some of the testing and the piloting. You've recently completed pilot scale validation. What does that mean, and why does it matter?
Yeah, great question. So, in our industry, in the process industries, we typically talk about earning our way into scale, and we start at a lab or a bench scale, we move to pilot, we go to some demonstration scale, and then eventually we get to full commercial scale. And we're taking that approach in our business too. With VTT and the existing capacity that they have in Finland, we've been running at the bench scale. To orient folks, that's about a kilogram an hour of plastic waste feeding a system. We've been operating at the pilot scale as well. That's tens to hundreds of kilograms of material per hour. So these are pretty large systems, but one of the challenges is that in those runs, we're sort of confined to running for days at a time or multiple days at a time. The challenge in this business of earning into scale is we've got to demonstrate operation and performance over a longer period of time. So I mentioned a little bit ago that in the back half of the year, really starting mid-year, we'll be standing up capacity here in the US to run for weeks to months at a time, to be able to demonstrate beyond that pilot scale to what we think of as mid-level demonstration scale, not our 10 kiloton commercial demo, but something in between, so that we can work out the bugs of operation, learn operating rhythms, learn where the system boundaries are, prove out what wastes we can and can't use, validate product quality, and really learn how to run the system for a longer period of time so that that can feed into both the design and ultimately the startup and operation of the commercial demonstration system in 2028.
Good. For both of you, and either one could take this question, you've sort of hinted at this a little bit, but beyond the technology, because Refinity is more than a technology, it's going to be a full company. What does the build out of Refinity look like in terms of supply chain, those kind of things? Can you speak to that? Either one of you guys.
Sure. Maybe Jesus, if you don't mind, I'll start and you can chime in if that works. I think, Chad, the best way to think about this is, as we talked earlier, the end game here is to create kind of a new industry that bridges between the waste industry and the petrochemical industry. At least that's how I think about it, right? Commoditizing plastic waste. We are developing and commercializing a disruptive technology that is necessary, but it's not sufficient alone. As you pointed out, this requires some business model innovation. So, we're working alone and with partners to build relationships with lots of entities along the value chain. That's, on the waste end, it's the waste collectors, the waste haulers, the aggregators and the recyclers who are already doing some level of separation. I can see building partnerships with other recyclers. To Jesus's point earlier, the mechanical recyclers have we both made the point that everybody has a place, there's materials that they can't use. So if one of those mechanical recyclers has raw materials that they process and can't use, we want to get access to that. That's part of the partnership development all along the supply chain. And so, it's the, as I mentioned, our core strategy as Refinity is to build and operate plants to start. Now, first commercial demonstration plant, that's smaller, although 10 kilotons of capacity is at least the same order of magnitude as where many players are operating in this space. Ultimately, we want to go 10 times, 15 times larger than that to be, at real meaningful scale. Our approach in doing that is to build plants adjacent to, tightly bound to the petrochemical industry, produce ethylene and propylene, circular ethylene propylene monomer, feed it directly into post-steam cracker operations at petrochemical plants. But what that means is we're sort of tightly bound geographically to being present on the site or near the site of those petrochemical companies. As a startup company, we need to be flexible. We need to be mindful of the fact that there's a lot more plastic waste distributed around the US, distributed in North America, and distributed around the world that we're not going to be able to access and bring to those centralized facilities. That's why we're pursuing this other path of being able to go to the same ethylene and propylene monomer, but then string it together to make liquids so that we can build distributed plants closer to where the plastic waste is, make a high value liquid product, and then ship the liquid around. Because frankly, it'll never be economic or even feasible for us to think about shipping over long distances the ethylene and propylene products that we make. The way I tend to think about this is that this gives us the opportunity, forces us to take the opportunity to meet the industries where they are. As a startup company, we're working to meet the petrochemical industry where it is by supplying drop-in raw materials that they're used to handling to take advantage of the infrastructure that they already have. If we think about distributing our plants closer to where the waste industry operates today, we're meeting that industry where it is, at least where it is today. 10 years, 15 years, 20 years from now, that may be different, and we may be able to do something different than that. But again, for us, as we think about building out, scaling up, and having the impact that we want, we've got to be nimble enough to do both of those things in a way that, frankly, others in our industry have not done to date.
Yeah, no, great. I really like what Bill mentioned, and I want to bring a complementary perspective to this discussion. And to me, is regulation, and the regulatory framework also needs to be ready for this transformation. We're transforming a system, and it still needs to scale up. Is certainly a lot of work needs to be done, and the circular economy that we're building as we speak is getting tighter and tighter because we're working towards gaining better integration. But at the end, and we can tell you based on experience, Dow is selling today mechanical recycling based products. We're also selling chemical recycle based products and also bio based products. And we're operating right now in a regulatory framework where there is a lot of voluntary goals, but there are no hard regulated recycled content mandates. So we have been pretty much advocating for making sure that the risk profile of scaling up our industry is can be managed, and that is based using making sure that there is already a well thought out regulatory framework. So there are two key pieces that I want to hone in here: is recycled content from mechanical recycle technologies needs to be recognized as a means to generating these recycled contents. There are mass balance chain of custody methods that needs to also be accepted. So it is very important, and we're in the middle of that right now because regulations are also trying to keep up to speed on all these new technologies that are coming to place, and building the right framework will certainly the risk that build out require.
If I can, Chad,
Yeah, go ahead.
can
Yep.
I tack on one additional comment to that? So I think, Jesus, thanks for that comment. It's really important because the point here is the regulatory framework is evolving at best. It's certainly not defined in a meaningful way. And so for us as a new entrant in the space, one of the things that I think we see as really critical, as I mentioned before, is being nimble, having a variety of different potential scales and plays that we can kind of either pivot to or track to as the regulatory frameworks evolve over time. And I don't know that I mentioned this earlier, Chad, but one of the other elements that we often talk about with the core technology that we have, but ultimately the business overall, is that we selected this technology, selected this platform because it's tunable, because it's flexible, and flexible means we can be robust to a range of feedstocks. As regulatory requirements change and maybe define a different suite of feedstocks that are more relevant than were before, we can track to that and we can adjust our process to accommodate it. One. Two, because we're tunable, we can make a range of products, gases, liquids, et cetera, to satisfy different industry requirements or satisfy different requirements in different industries. And then finally, the flexibility piece I mentioned about the geographic flexibility, it allows us, and scalability, it allows us to match our capital deployment risk, the size of the plants that we deploy, to the needs of the industry at a given point in time. Ultimately, as we get bigger in scale, the economics will track and be more attractive. But we have a pathway, a pragmatic pathway to get there. Whereas for many other players, it's sort of one scale and done. And so I think, in terms of build out and reducing the risk of build out, we've thought through that earning into scale approach in a way that that builds on our process industry experience, and I think is something different than what other competitors that we've seen over the years sort of not do as well as we think we're doing.
Good, great. I have a question for both of you. I want you guys to kind of speak to this if you can. Let's zoom out for a second. 5 years, 8, 10 years out. Refinity hits all the milestones, achieves what you hope it does, what you think it can, what we hope it can. What does the plastics industry look like then? What kind of impact would that have on the plastics industry? Either one of you want to take that?
Maybe Jesus, why don't, if you feel like taking it from your perspective, from the industry's perspective, if you can offer something, please do. And then I have a Refinity centric view of that. You have an industry centric view. Maybe that's a better place to start.
Yeah, no, absolutely. Zooming out a little bit, I've been in this industry, as I mentioned earlier, for 7 years. Been very fortunate to see a lot of very cool technologies that we thought that could scale up faster, and they certainly haven't. Others, there have been a lot of great progress in certain areas, but at the end, when you look at overall, it is taking time to build up this industry. And because of the lack of the regulatory certainty, also there is not a lot of funding flooding this our circularity industry. So all this system that needs to get rebuilt needs really good and clear and impactful proof points to build that credibility, to advance that regulatory framework, to advance the reliability and consistency of delivering as circular plastics as the industry expected, because we built the linear economy of plastics for the last 80 years, and our customers today are expecting to receive reliable supply of products and consistent. So ensuring that the circular pieces that we're building continue to produce that consistent and reliable products is quite a challenge. And having more proof points, having more pathways to accomplish that really help us all. It helps the whole industry, as Bill mentioned earlier in the discussion, where now we become an industry that is scaling up with proof points, announcements that become real pounds being sold in the industry and at a scale, and it really helps the build the momentum that our industry needs.
That's good.
Thanks for that, Jesus. It's interesting because your comment about time and industry resonates. There are technology companies, competitors, particularly pyrolysis companies that I looked at for the first time, I don't know, 15, 20 years ago, some even longer than that. Some have progressed, many have not, many don't exist anymore. And so I think a way to summarize all this is that this is really challenging. I mean, we're trying to take a waste stream that is not uniform, that is not yet commoditized, that's highly variable, and turn it into a feedstock that we can then transform into drop-in hydrocarbons that, in an ideal way, are indistinguishable from that which are made from the fossil raw materials that the industry uses today. That's a tall order. And in fact, many companies have failed at it over the years, and it creates headwinds for all of us that are in this business. So back to your original question, Chad, from the 50,000 foot view, what does our success do? What does it mean? I mean, number one, it's a credible proof point that this can be done and done at scale and done in a way, again, when we achieve what we say we're going to achieve in a highly integrated way that meets the industries where they are today. So rather than making some liquid intermediate that has to be upgraded and shipped around and then used as an alternative feedstock that's always not quite the same, always, maybe a little bit inferior, or at least not to the same standard as what raw materials are today. And that's what other recyclers have often done. We want to make a drop-in product and pipe it from our process directly into the petrochemical plant in a way that day in and day out, we can crack plastic waste and turn it right into the feedstocks that the industry can use. That proof point, I believe, will be unique and different and lend a level of credibility about what's possible, no matter what scale it's done. When we do it at the 10 KTA scale, that's a gateway to just lots more opportunity. And again, back to the original point, I think that is a critical proof point along the way to then creating the right incentives for regulators to realize, this can be done. There's a reason to put the right framework in place. For waste haulers to say, I can start diverting some of these wastes that today go to landfill and incineration to advanced recycling. For consumers like all of us to maybe require of our municipalities or demand of the infrastructure, the supply chain, that the waste that we produce actually go to a process like this. So I think it's a gateway to change the future.
Yeah, I mean, we've thrown a lot of technical jargon out there and we've talked about, regulatory requirements and all that. But imagine a world where waste is a commodity, plastic waste is a commodity. I mean, that's exciting stuff. At the end of the day, it's a game changer. It could totally change the economy. It changes how we view plastic and how we view waste. It's super exciting to think about.
Absolutely.
We're coming down on our time. But before I close, I want to say, is there anything else you guys want to cover that we haven't covered? Anything else you want to say before we close out?
Well, I'll add that, Jesus, I very much appreciate the collaboration, and we look forward to working together over the next years to figure out how to make all of what we just talked about a reality so that waste can be commoditized and we can drive circularity that makes money for the industry in a way that it currently can't and satisfies the sort of the broader impact needs that we all want to see develop. So thanks for the collaboration.
Thank you, Bill. And from my end, I'm also very thankful for being invited to this podcast. And I really want to encourage those that are thinking about coming to our industry. Please come. This industry has been around for many, many years, and plastics are really foundational for everything that we do and everything that is coming in a world that is going to need more and more resources. We just have to just build efficiencies, and we're just we're reimagining, we are redesigning the world as we speak, and it's super exciting to be in our industry today. So I will encourage everyone out there listening to our podcast to really think about joining us. We need sharp brains, but more importantly, we need passion. We need you to bring and help us bring perspective to advance this to the next level.
That is a great note to end on. Thank you, Jesus. Thank you, Bill. I appreciate the time. I look forward to seeing what's coming next from this partnership. Super exciting stuff. Thank you both.
Thanks a lot, Chad.
Hey, if you have questions for us at Innventure, just feel free to reach out to us at letstalk@innventure.com, or you can just find us on our website at innventure.com. That's 2 N's, INNVENTURE.com. Thanks.